Hello everyone. Today we are starting a new topic which is on the LIDAR technology. So this is lecture 32 and in this lecture you will understand the basics of the LIDAR and the laser beam which we are using, and also what are the different equipment which we like to use in geomatics engineering. So let's begin the lecture. So first of all you have to understand the laser. In fact, the expansion of the laser is light amplification by simulated emission of radiation. So, any device which generates the light wave and using a very narrow band of the spectrum, that's called the laser. We can see in the diagram also the sensor is generating the very pointed, very sharp laser beam. So typically this is a low divergence beam, and but it has a well defined wavelength, and it corresponds to a particular color. As we know, in the wavelength region we define in terms of the color also. If it is operating in a visible part of the spectrum, it is related to the color. These lasers are similar to the transistors because they are generating the beam, they are amplifying the beam, and these electronic signals are amplified at audio, radio, and microwave frequencies. So, similar to that, we are working with the laser also. Now, there is another terminology along with the laser when we are working in geomatics engineering. This is a LIDAR technology. So, what is the difference between the two? Because these two terms have been used synonymously. So, laser basically is a device which can produce this monochromatic coherent beam, very well defined beam of the light. While LIDAR, LIDAR is a uses the intense pulse of these laser lights. So, if we have several of these laser lights, very intense pulses to um, um, take the measurements of the different structures and different objects, uh, then this that is called the laser. And we have the devices, laser LIDAR based devices which are using the laser beams. So these devices, they have um, very dense beams of the light, maybe the pulse white light, and they are depending upon the design and the configuration of the system as well as the application of the system. So, laser beam is a pointed beam, while the LIDAR will be a mesh in network or dense several beams together. So, in a laser based unit, we are more pointed towards some object and carry out the measurement with the help of that device. Now, we have, for example, the uh, instrument which can measure the distance with a laser beam. So, very small replacement of the tape with the laser based measuring devices are available. We can actually scan some area, we can scan the chosen point, selective points, and the data from this laser based devices is coming out to be very slowly, but it is quite accurate data because it's a well pointed beam. So, it's a accurate data, but it is a slow data. But while in the LIDAR, because this is in continuously in motion, when we are taking the observation, whether it is on the ground or on the aerial platform, and a very large number of laser beams together are traveling. So, they are sweeping a very large area and collecting millions of points together. So, at a very fast speed. So, we are getting a very large area covered in the very short period of time with the help of the LIDAR devices, while laser beams will collect the data more slowly, but it will be much accurate than the LIDAR. Now, both are scanning methods, both have the scanning mechanism, and ultimately the output which we are getting from these two, we can create 3D model of the area, we can create the profiles, elevations, etc., and we can use that for digitizing various objects or surveying or mapping the terrain. So, these are some of the possible applications of this. Now, these laser systems which we have, laser scanners for example, they are using infrared lasers that will strike to the object and bounces off. And then how much time it has taken for the ray to travel to the object and coming back to the system, that is measured, and they can very well observe the minute details when we are working with those laser systems where the beam is very much pointed towards the object. Small holes, small cracks, diameter of a small object we can find out with a very high resolution because the focused beam will strike to the object. Now, by minimizing this contact area, we will reduce the chances of errors also, which we are getting in the LIDAR based systems when we are throwing large number of beams. So, we have uh, less error in our database. So, edges or the corners, they are adversely affected by the return signal. So, we are basically getting the very good data from these systems. These systems can reach to those targets also where it is not possible for the human being to go and take the measurements, put up some device and take the measurement. So, very difficult access, difficult area, difficult terrain, we can actually use these devices, and the results of such devices are used in aerospace industry, automotive industry, where precision is more important, where with the minimum intuition of the human being, we can get highly precise data. So, there these have great applications. Now, coming to the LIDAR technology, when we are doing scanning of the surface by LIDAR systems, it will measure the distance by illuminating the target. It will send the pulse of the light to the target and will actually measure the time of the travel it takes to reflect off from the target or to return to the sensor. So, again, it is working similar to a radar system. As we know that the distance is calculated by knowing the velocity of the spectrum, which is in the visible part, velocity of light multiplied by the time. So, we can get the distance. Some of the instrument can measure the phase difference. So, that phase difference is also used too because the time measurement of the time may not be that accurate. So, phase difference is also used to calculate the distance. Now, we have portable long range 3D laser scanners which can be used within a room, within the buildings, to know these aircraft details, ships or similar size. You can recreate these kind of structures, and you can measure the dimensions from this particular data. And also portable type we are using very much in construction industry for our engineering works because they are providing us also very high accuracy range. So, accuracy range could be from 0.75 to approximately 3 millimeter accuracy. So, very high accuracy data can be obtained with the help of these lasers based devices when we are scanning the surface. The LIDAR technology we are very much using in our surveying and mapping also because it has a lot of applications. Once we are getting three-dimensional coordinates from this particular device, then those three-dimensional coordinates are used for surveying and mapping purpose, and also in GIS that data can be used. Uh, to aircraft or the automobile, when the LiDAR is collecting the data, we can actually put the GPS also. So, we can get a very large swath of the terrain along with the very accurate coordinates where we have taken the data with the help of the GPS devices. So, GPS is helping us to get the real world coordinates now of the data which we are collecting. This LIDAR we can take in the field, portable type, we can mount it on a airborne system, which could be drone, which could be a aircraft system, or maybe we can mount it sometimes on the vehicle based LiDAR systems are available. So these systems all are collecting the data in the different modes. Now the accuracy which we are getting from this is 2.5 millimeter to 30 centimeter accuracy. So it depends upon the type of instrument which we are using. It depends upon the uh, method adopted to collect the observations, but their ranges are very long in kilometer. If there is a visibility, if you can see the terrain before you, then they can take the observations kilometer long. So this technology is a wonderful technology which was not available earlier, can take kilometer long data with such high precision. There are several utilities of the LiDAR data which we get, which we collect out in the field, and the advantage is that we get high degree of automation, because these devices can automatically, once you define certain input values, then they can automatically collect all that three-dimensional data for you. So very high degree of automation is there, minimum human intervention is there, their operation is very safe, and particularly where the human being cannot go, where it is a difficult terrain, one can collect the data very safely without going to those dangerous areas. This is less affected by the atmospheric condition. As we know, the satellite images are affected by those atmospheric condition. Our GPS observations are also have some error due to the atmosphere intervening, but they are less affected by the atmospheric conditions. And this is a very efficient method of data collection, very fast and very quick um, data collection for a large area. And later on you have to post process the data, you have to process the data, so efficiency is also very high for post processing and getting the desired results. So these are some of the utility why we should go for LiDAR data, and this is the laser principle on which all the LiDAR based devices are based. Now if you look at this particular diagram here, we have a transmitter, we have a receiver here, and we have some device, clocks for reading the time, etc. Then beam will transmit. So you can see the beam will be transmitting from the transmitter, laser beam, and will strike to the object, to the target surface, and it will return back, and the receiver will receive that, and this distance d can be calculated, same basic equation, distance is equal to velocity on time. So all our laser based devices, LiDAR systems, are also based on the similar kind of a principle. Now we have the point laser devices. As I mentioned that some of the laser devices will actually generate single beam, right? So it does not take very large, it doesn't cover very large area at a given time, as you can see in the slide also, that the instrument is actually generating the point beam which is red and striking to the object. So we are getting the data from one single point, x, y and z coordinates of that single point at any instant. So point by point it's going to collect the data. It will take very small scan at a given time, but the accuracy, if you want to achieve very high accuracy, this will give the accuracy. So speed wise it is slow, but resolution of the data is absolutely very high. Now let us talk about those scanning devices, which can scan a very large area in a very short period of time. So you can see here this LiDAR system is capable of collecting very large amount of data in the shortest possible time. Now it will send the pulses of continuous series of the laser beam. So that is the biggest advantage of it. So when it is sending the pulses, several pulses of the laser beam, so they will cover in one go a large area, and that's how the entire area is covered very quickly. So these pulses will travel common to the axis of the laser, strike to the object, and reflected one will be captured again by the device. So this device has another advantage, and the advantage is the rotation of it. So one rotation is about its vertical axis, so it can rotate 360-degree about its vertical axis in a horizontal plane. The other could be rotation about the in a vertical plane rotation, and that could be roughly 310-degree to 320-degree. So in x and in y direction the rotation, and due to the rotation we can cover from one single point a very large area. That is the biggest advantage, and this all is automated once we define how much area, how much field of view is to be covered. So output from this will be point cloud data. That means in terms of millions of points whose coordinates are known to us, x, y and z coordinates are known to us, and these points we can use either for mapping purpose or creating a 3D model of the area or carrying out any measurement of that particular device. Now you see in this diagram here that 360-degree rotation is there about the vertical axis, and about the horizontal axis about 310-degree rotation in this way. So when we have the two rotations, a very large area around us will be covered, provided there is a clear visibility to that area. Now if we look at the classification of these LIDAR systems, they are three broad classifications. So one is the terrestrial laser scanner, short form is TLS. This terrestrial laser scanner, we are actually very close to the object, we are close to the ground and taking the observation. It's like a terrestrial photogrammetry where you are closer to the object and you are taking very detailed information, collecting very detailed information about that object. So the instrument is on the ground very close to the object and taking very high resolution data. Then we have the mobile laser scanners. That means this scanning mechanism, these devices are mounted on some platform which is mobile, maybe a special kind of a vehicle on which we can mount this system, and this systems can move and collect the data for a large area. Then we have the third one which is called airborne laser scanner, ALS. So here in airborne laser scanner we are mounted this further up, maybe in the aircraft, maybe in the drone system, UAV system, and it will cover a much larger area in the shortest possible time. So let us understand one by one working of each and their utility and the merits. So in this lecture we will cover only the first category, which is the terrestrial laser scanner. So there are very large number of terrestrial scanners which are available in the market with different specifications, with different range. So they give you different accuracy and different range, depends upon the specification and the price of these devices. So there are some which are face based. These scanners will measure the face in order to compute the d distance, while the previous one which I showed you, they are based on the time of flight. So if we know the time, we know the d distance. So these are the two approaches, face based and the time of flight based. So these are available um, in the market commercially, but along with that instrument, when we are working in the field, what we require is we require some other peripherals. Like you can see a person here is working in the field, then he has some laptop devices so that can do certain computation and can see the and providing the controls. So we have some kind of a reflector or the targets where we want to very accurately measure the coordinate and provide the control to our whole work, and this is the terrestrial laser scanner kept in the ground. So a combination of these is required in order to carry out the work. Now, when we see the close up of the target types, there are different target types available. Some reflecting type, some non-reflecting type are available in the market, and these targets are to be fixed when we have to minutely observe the object. Like we want to monitor the deformation in the dam. So, we will put this target on the dam face and continuously monitor, regularly monitor the coordinates of these target points and come to know the deflection if it is taking place. Now, this terrestrial scanner, now it is now set up on the ground and it is linked to my laptop systems. And then what is happening is now it is trying to collect the data of the building or the structure. So, the dots which you see here is that point where the laser beam is striking and collecting the data of the XYZ coordinate system. So, XYZ coordinate system is also shown here. So, that way line by line it will uh, scan the whole of these structures, and at the end you will have lots of data. But if you want to study in 3D, and sometimes we want to study in the 3D, so then what we do is we will like to collect the data from the two different points, different distances. The distance is known and the same object is scanned from the two places, and we can actually use that data in a much better way for registration purposes. So, we can make the registration because we have the common points between the two scans, and we can create a better model out of it. Now, let us see the further categorization of the terrestrial laser scanner. So, depending upon the use and depending upon the application, they are available in the different uh, categories. One is the panorama scanner. Panorama scanner is, as the name suggests, that it can take 360-degree in the horizontal way and 310-degree in the vertical roughly data. So, if you keep at a point all around, it will cover the whole area as in is shown in this room. So, this is kept in a room, and all the faces of the rooms including the top and the bottom uh, have been all scanned. So, data has been collected very quickly in a short period of time. Then we have the second category, which is called the hybrid scanner. And hybrid scanner, the rotation about the vertical axis, the horizontal one can move 360-degree this data, but the vertical is restricted in that case. So, one rotation is free and one is restricted in that case, in the hybrid case. And the camera scanner type, where you have to change the direction every time. So, it will actually scan only that area which is covered from one particular distance and one particular angular direction. Now, we have uh, two kind of laser scanners, terrestrial laser scanner. One is the dynamic laser scanner, another is a static one. So, dynamic one is that when we are using it on the road and the track in the mobile mapping mode, then this is called the dynamic laser scanner. But static laser scanners, as the name is suggesting, we are keeping it at a point, taking the observation, shifting it, and then taking the observation like that. They are available in different ranges. So, the range here is starting from the close range, which is 0.5 to 2 meter. So, you are as close to the object by taking very minute observations, cracks, small cracks which are not visible, that also can be monitored, or the deflection can be monitored. Then we have the medium range, which is 1 to 150 meter away we can be from the object which we like to collect the data. Then we have the long range, where we can have say 1 kilometer distance, 150 to 1 kilometer. So, each of this has its application. If we are talking about the close range, we are very close to the object, we are using for body scanning, we are using in the medical science, police department is using for applications. फिर medium range could be cultural heritage, could be geological application in civil engineering, in facility management. But long range are used normally for monitoring, city modeling or mining activity. So depending upon our application, we like to go for the terrestrial laser scanner because the cost is also associated with the range part of it. Now this is the entire scanning process. We are setting up the scanner, and we are creating the point cloud data of the real object. So this is the object point creating the point cloud data, and then later on, using the capabilities of the software, a 3D model of the point cloud data is created. So this is how we have to do it. Now when you are collecting the data, it will collect millions, several millions of points for one object. Now it depends upon the density, at what density the data is being collected. So you can see here those different small dots, and each dot has three dimensional data attached to that. So along with that point cloud data, there are certain objects which are not required at the end. So that means the editing of the data would be required once you are collecting the point cloud data. There are certain artifacts, there are certain unwanted objects which you don't require. Suppose you have in the surrounding of the buildings the other objects, that will also be scanned, but we want only that particular building. So all that this 3D point cloud data which you are collecting, now you are doing the cleaning of the data, and then at the end you are getting the x, y and z data, so that this x, y and z data is error free, and directly either the CAD software or GIS based software we can use to create 3D models of the area. So we have to use the appropriate software, and these are the steps when we are processing the data. So data processing is also important along with the data collection, because there are certain errors which we are removing, there are certain artifacts, there are certain points which we don't want in our analysis. So we have to do that editing of the data through the data processing. Then we can get the reflectance images also. This, if we create the image, it will look like a black and white photograph from that. And the highly reflecting points, light points, are displayed in the light gray pixels, whereas the highly absorbing, there are certain points which will absorb the beam, so they will appear as a dark gray pixel. And if there is no return from the object, then that will appear as a black pixel. So if we see that in the form of the gray shades, we should know what is the relationship of the reflectance of the gray values with the type of object which is present. So this is a 3D laser scanner which we keep on the ground, terrestrial laser scanner which we are keeping on the ground and taking the observations. So here you can see the person is taking the observation of a bridge, and there is a road here, and then ultimately creating the model, 3D model of that road with the help of the X, Y and Z data. So we can use it for dam, we can use it for bridges, tower, structures and buildings in much faster way. And also if we are continuously monitoring these objects, maybe we end up determining if there is any deformation which is taking place, if there is any sinking of the object, if the object is inclining, if the cracks are being developed. So that all can be monitored because we are very close to the object and monitoring this object regularly. So this also shows the top view here, the data which has been scanned with the help of the terrestrial laser scanner, and this has been done all automatically. So if I show you the close up of a building, down below you can see the actual building, and the top view is the view of that building through this terrestrial laser scanner which has created a point cloud data. Now we can carry out each and every measurement of the building components with the help of that. So this is again another view of the building mapping which is being carried out with this kind of. So we can use for bridge, so bridge deformation, or maybe monitoring these nut and bolts also, or if there is any crack developed, so that, or is there any the deflection which is beyond the limit when there is a heavy load passing on it, that also can be carried out. So this is a the recreation of the 3D point cloud data of a particular building. There is a software which has been used here. The Cyclone is the name of the software. So you can have now measurements, several measurements once you have created this. This is showing the deflection. You can see a curve. So basically this is one end of a beam, another end of a beam, and this shows that how the beam is deflected when the load is put on this, and terrestrial laser scanner has been used. So it has lot of applications to minutely observe the changes which are taking place. So application part, when we look at the application, we have slope stability monitoring application in forestry, in shipbuilding, forensic, biometrics, heritage preservation, in construction industry, deformation I have already explained you, in architecture, in archaeology, and creating the virtual reality of the object in our computer. So if I summarize the lecture, the laser based devices, LIDAR technology is giving us 2D and 3D data very rapidly, very efficiently, very accurately. You can collect large volume of data and you can use it either creating a 3D model, carrying out the measurement, or create the visualization from this data. This also requires a calibration of the instrument. This is very important if we want to improve the geometric quality of the point cloud data. Then calibration is required with respect to some known point. So this is all about the terrestrial laser scanner. Thank you.